Yeah, hello friends. Today we are going to discuss about applications of PN junction diode. So we have enormous applications of PN junction diode, but in our curriculum only the three applications are given. One is a switch, other is a clipper, and third one is a rectifier. Today we are going to discuss about rectifier. So before discussing any topic, first I have already told you we have to raise these questions in our mind. That is what, why, when, and how. Okay, that is what is that particular topic. Okay, what is the definition of that, why we have to study this, where do we apply this, and how the operation is all about, how it is going to function out. So first one we have rectifier. What is a rectifier? So rectifier is an electronic device which converts AC to pulsating DC. AC to pulsating DC. Then what do you mean by this pulsating DC? Here AC nothing but usually AC will be a bidirectional waveform. If it converts a bidirectional waveform to a unidirectional waveform, then it is called as a rectifier. Is it clear? Then why we have to study this rectifier? So I'll give a practical example. In order to do charging of your mobile phone, we are taking the help of either charger or adapter, isn't it? In order to do charging of any mobile phone, we are taking the help of charger adapter. So why do we need that particular adapter or charger? What is the main functioning of that adapter? Here this particular adapter is converting what? AC to DC, isn't it? AC to DC. This DC is now required by all the electronic components. Okay, I think but this particular DC supply you are given to your mobile phones or cell phones, and this mobile phone is again internally what happens, it is made up of what? All the electronic devices. So do remember, almost all the electronic devices they need water, that depends only on the DC supply. Okay, that depends only on the DC supply. Okay, because these are very sensitive with respect to temperature, and even the size is also very small. So if we give AC directly to these electronics components, they can't tolerate that much of supply. Simply they are going to get damaged. Okay, so simply they get so damaged. So for this I will give an example. See here, if your eating capacity is only two chapatis. Okay, if your eating capacity is only two chapatis, but if someone is forcing you to consume additional one, to consume 3 or 4 one, isn't it? But what happens after that? If you consume it, then your digestive system is going to be damaged, isn't it? Some defaults is going to be occur in your digestive system. So similarly here also the maximum capacity. Okay, these electronic components, electronic devices, they function only with DC, they function with only unidirectional current flow. Okay, but if we give directly to the AC supply to these components, they can't tolerate that much supply. Simply they will be get damaged. Is it clear? That's the reason we have to give a DC supplies to it. Then here we have what? Adapter. Here we have adapter. To this adapter we are giving AC input, and it converts this AC input to the DC. Then here we are going to discuss about what is happening in this adapter. What are the various circuits we have in this adapter? So in this one of the circuit we have is rectifier. Okay, which converts AC to pulsating DC. So if we discuss in detail about what individual blocks of this adapter, so first one will have water. This particular box charger is called as a DC power supply, or simply RPS, that is regulated power supply. What do you mean by regulated? We can control. Regulation nothing but what? Control. Just like you for every fan you can have what fans, you can have what? Regulators, through which we can control the speed of electron. So just like in the similar fashion we can control the output DC current by means of this RPS, regulated power supply. So in that RPS, the first block we have what is transformer. Okay, the first block of the RPS we have what? Transformer, and the successive block of the next block of the transformer is what? Rectifier. The next block of the transformer is rectifier, and the third block we have is filters. And the fourth block we have is regulators. and the fourth block we have is a regulators. So at the output of the regulator we are connecting a load. It could be a resistor or whatever it may be. At the output of the regulator we are connecting a load by means of a resistor. So coming to this, then why do we need this transformer in the RPS? Because see here, in transformer we have two types. One is called as step up transformer, second is a step down transformer. Step up transformer and step down transformer. What do you mean by step up? Means if it increases the input voltage, then it is called as step up. Whereas if it decreases the input voltage, input AC voltage, that to input AC voltage, if it decreases the input AC voltage, then it is called as a step down transformer. So here for our applications, that is for almost for every application of electronics, we go with the step down transformer. So here what is the input of the transformer we have? The input of the transformer is 230 volts AC and 50 hertz, which we are getting at home, isn't it? This 230 volts AC now step down. Okay, this particular transformer reduces this 230 volts AC to certain extent. Let us consider it is decreasing this input voltage. It is decreasing this input 230 volts AC to certain 9 volts AC. 9 volts nothing but decrease in the magnitude. From 230 volts magnitude to the 9 volts magnitude. So decrease in the AC. Now this 9 volts AC now act as input to your rectifier circuit. So which particular electronic device acts as a rectifier circuit? It is nothing but diodes. So diode is an electronic device. Now it converts its bidirectional AC, okay, the bidirectional AC to the unidirectional or nothing but pulsating DC. Pulsating DC. So here, do we get the pure DC here? No, we did not get pure DC here. Pure DC nothing but it should not vary with respect to time. There should not be any fluctuations in the magnitude. If we have any fluctuations like this, okay, this is called as ripples. Are AC components. Then these AC components are undesirable or unwanted. Then why we have given the name as ripple means just like it is resemble the structure of a ripple. That means if you have thrown a stone in the water, then what happen around the particular surface of that stone, you can find the ripples in the water, isn't it? Just like in this shape. That's why they have given the name like a ripple. So ripple nothing but what? AC components. So here the amount of AC components which are present in the rectified output, is called as a ripple factor. That is measured by means of a term called as ripple factor. So ripple factor nothing but the amount of AC components or ripples present in the rectified output. So since here we did not get pure DC at the output of the rectifier, now this particular pulsating DC act as input to the filters. So internally, what is filter? We have seen the purifiers or water filters at our home. What is the function of purifier or water filter at our home? So it has to filter out the dirt particles from it. And must give the pure water, isn't it? Similarly here, the dirt particles we can compare it with the AC components or the ripples. So we have to eliminate these dirt particles, nothing but AC components from the DC in order to get the pure DC. So for this we use these filters. So which particular device we use as a filter means it is the capacitor. So in that particular circuit, we take the help of the combination of resistor and capacitor which act as a filter, which filters out the ripple components from the rectified output, so that the output of the filter becomes like this. Just almost about to equal to DC, but with small amount of ripples in it. And finally it gives to a regulator. So here who will be functioning like a regulator means it's a Zener diode. So Zener diode functions the role of a regulator, and finally it gives the constant DC voltage as the output, which is given to your, which is supplied to your final end, final load, nothing but could be the cell phone or whatever it may be, the load which you are connecting. Is it clear? That is nothing but the RPS or the regulated power supply is all about. Thank you. That's it with today's session.